Hello everyone. So in today's video, we'll discuss compound interest. In the previous video, we discussed that what is interest and what was simple interest. Let's see what is different here. Compound interest is what is the difference between simple interest and compound interest? Fine, let's try to understand it. Now, we know that what was simple interest? Uh, if you borrow something from a person and the extra amount you pay is called interest. And we know that the simple interest remains same every year. Let's try to understand it in this way. See, if you borrow 1,000 rupees at the rate of 10% from a bank, you'll have to pay 100 rupees, 10% of 1,000 as an interest. So the amount due at the end of year will become how much? 1,100. Now let's say you want to use it for one more year. That means another year you'll have to pay 100 more interest. That means the total interest becomes 200 and the amount due will become 1,200. If you use it for one more year, again the principal remains same and the total interest will become 300 because interest remains same every year. So the amount due becomes how much? 1,500. Now this is what we call simple interest. That means effectively you end up paying 300 rupees extra here. If you borrow 1,000 rupees from a bank at the rate of 10% per annum. Now, what was the drawback here? I'll tell you. See, I borrowed 1,000 rupees. At the end of one year, I should have repaid how much? 1,100. But let's say I want to use it again. So next year, bank should have charged interest on this 1,100 instead of what? This 1,000. That's the drawback here. So if you look at the case of compound interest, if you borrow 1,000 rupees from a bank on compound interest, the interest payable at the end of one year will become 100 and you'll have to return 1,100. But if you don't want to repay, you want to use it again, next year, bank will charge interest on this 1,100 instead of this 1,000 rupees. Yes, sir. Now, what is 10% of 1,100? 110. And the previous interest was 100. So this total interest will become 210. That means amount due at the end of one year will become that principal 1,000 plus 210 is the interest. That gives you 1,210. Now let's compare this 1,210 with 200. 1,200. You're getting 10 rupees extra here. That was the drawback of SI system. That's why a new system came called compound interest. Here, you'll be getting interest on interest. So actually, it's nothing but the successive percentage change here. Look at this. This 1,000 was your principal. Let's say you want to use this money for one year. So this 1,000 will become 1.1 into 1,000. Your money will grow by 10%. Now let's say you want to use it for one more year. So I need to multiply one more 1.1 because now this money will grow by 10%. That's why I'll have to multiply the previous value by 1.1. If you want to use it for one more year, I need to multiply it by 1.1. Which value? The previous one, which was the amount due at the end of 2 years. So effectively, this becomes how much? You get 1,331. And in case of simple interest, it was only 1,300. So you can see a difference of how much? 31 rupees here. So this was beneficial for bank or the person who's going to lend the money. Yes, sir. That's the basic difference between SI and CI here. Now let's try to understand it. Now, why do we need that system? You know that drawback. I've already explained it. Now, were the lenders being greedy? No. I know that the interest will be charged on interest here. Okay. So what is compounding that? It's nothing but the successive percentage increase. Can I say like that? Because I know that 1,000 was multiplied by 1.13 times if the money was lent for 3 years. So effectively, it becomes how much? 1.331 into 1,000, which is equal to 1,331. Yes, sir. So what's the compounding? Is the process of assuming the total accurate amount at the end of any period of time to be the principal thereafter. That means in this case, the principal will always change. If you borrow it for one year, the principal would be different. If you borrow it for 2 years, after one year, you need to change the principal. Fine. Let's look at few questions here. So let's try to generalize it. What is compound interest? So let's try to find the amount first. If you borrow P rupees at the rate of R% for n years, how much amount you'll have to return? I know that it's a case of what successive increase. The speed will increase by R%. So I should multiply this multiplying factor 1 plus R by 100. You borrowed the money for n years, so I should raise it by n. This much amount you'll have to pay at the end of how many years? N years. So what's the compound interest? We know that compound interest is always equal to amount minus principal. Yes or no? So amount minus principal. What's the amount here? We have already seen that P into 1 plus R by 100 raised to the power n minus P. So the value of compound interest would be this much. If you take P common, what do we get? 1 plus R by 100 raised to the power n minus 1. Yes or no? So this becomes the formula for what? The compound interest. Or what you can do, you can find the value of amount, subtract the principal from this part. Now let's look at few questions here. What's given here? Calculate the amount due on 15,000. So this becomes your principal. At the rate of, so this is R and this is N. What do you want to find? Amount of compound interest. You're looking for amount. So what's the formula of amount? Amount is equal to principal. That is 15,000 into 1 plus rate of interest is 20 divided by 100. It was borrowed for how many years? I'll say 3. So effectively, what do we get here? 15,000 into 1.2 raised to the power 3 here. Now, what's the cube of what? 1.2. It's a 1.728. So the answer will be 15,000 into 1.728. So it comes out to be 25920. So what's the amount payable? I'll say 25920. And what was the principal borrowed? That was 15,000. And the difference of these two will give you what? The compounds. Let's look at one more. What will be the CI, that is compound interest, compounded annually on 20,000 for 2 years at 15% per annum? Okay, let's try to calculate the amount first. Principal is 20,000 into 1 plus what's the rate of interest? It's 15. Was borrowed for 2 years. So the amount payable at the end of 2 years will become 20,000 into 1.15 square. What is 1.15 square? We'll say 110. Sorry, it's 13225. That is 1.3225 into 20,000. Comes out to be 26450. So this is not the compound interest, this is amount. When you're looking for what? The compound interest. We know that compound interest is equal to amount minus principal. What's the amount here? 26450, which is payable after 2 years, minus that principal, 20,000. So effectively, the compound interest comes out to be 6450. This is the compound interest on the given sum at the rate of 15% for 2 years. Let's look at one more question. A certain sum P lent at R%. So P is unknown, the rate of interest is unknown, CI compounded annually amounts to 8,000 in 4 years. So if you borrow that P rupees at the rate of R% for 4 years, it will become how much? 8,000. So I should write 8,000. And to 9680 in 6 years. The amount will become 9680 on same principal P if we'll borrow it for how many years? 6 years. So this becomes 6. And you're looking for what? R. Look at both the equations. Two variables are there. It's better to divide both of them. When you divide both of them, what do you get here? You get 80,000, sorry, 8,000 by 9680 is equal to this PP will be cancelled out and these four powers will cancel it out how many times? Two times, four times. So you will left with what? Only two powers. Or I can write it like this 1 by 1 plus 1, 1 plus r by 100 square must be equal to 9680 by 8000. Yes, can we cancel it out by 8? Look at this one. This is 8 into 1, 8 into 2, 8 into 1. This is 8. This is 1000. So effectively, this comes out to be 1.21. Now, 1 plus r by 100 square is 1.21. So can we say 1 plus r by 100 should be equal to 1.1? Or the value of r will become what? 10%. So what was the rate of interest? It's 10%. So we'll have to calculate. Now, this was a conventional method to solve these kind of questions. Fine. Now, how do we solve it? Using a shortcut. Look at this. If you borrow B rupees from bank, it will become 8,000 in how many years? 4 years. And if you wait for 2 more years, it will become 9680. So what's the increase in amount here? Look at this. It's 1680 rupees. Yes or no? In how many years? 2 years. And we know that this increase is nothing but the interest on this 8,000 rupees. So getting an interest of 1680 rupees on what? 8,000. Yes or no? So there's an increase of 1680 rupees in 2 years. In 2 years. And we know that this is nothing but the successive percentage increase. So can we calculate it like this? 8,000 into 1 plus r by 100 whole square will give you how much? 9680. We can do it directly also. Now 8,000 into 1 plus r by 100 square is 9680. That means 1 plus r by 100 whole square is equal to 9680 by 8,000. Look at this. Both the equations are same. You get it directly here. And this was equal to how much? 1.21. So 1 plus r by 100 becomes how much? 1.1. That's why the value of R becomes how much? 10%. So this can be used as a shortcut. Fine. Let's see another one. A sum becomes three times itself under a certain rate of compound interest. We've already seen these kind of questions in simple interest also, but it's a case of what? Compound interest. That means if you deposit a principal of 100 rupees, the amount will become how much? 300. In how many years? Time period is given equal to 30 years. The rate of interest is missing, so you'll have to find the value of R first. Am I right? Okay, let's see. What was the amount? It's 300. Principal is 100 into 1 plus R is unknown. Raised to the power how much? 30. So what do we get here? 3 is equal to 1 plus R by 100 raised to the power 30. If you apply the property of indices here, what do we get? 1 plus R by 100 should be equal to 3 raised to the power 1 by 30. So I know that this is a value 1 plus R by 100. Now what's the next part of question? In how many years will the same sum becomes 9 times itself? So let's try to apply this formula again. 9 times itself means amount should become 900. What was the principal? 100 into 1 plus R by 100 raised to the power how much? N. And we don't know the value of R here. We don't know the value of N here. But look at this one. The rate of interest was same. That's why this 1 plus R by 100 can be replaced by. Can we write it like this? 900 by 100 is equal to 1 plus r by 100. It can be replaced by 3 raised to the power 1 by 30 raised to the power n. Now, when you multiply the powers on the right hand side, what do we get? This 9 is equal to 3 raised to the power. These powers will be multiplied. This becomes n by 30. And I know that this 9 can be written as 3 square. So what do we get here? Bases are same. That's why the powers should also be equal to same. The powers must be equal. Now, powers must be equal. That's why 2 is equal to n by 30. So, what do we get here? N is equal to 60 here. Now, if you remember the previous question which we discussed in the class of what simple interest, same data was there, and the answer of time period was 120 years. But in this particular question, your value, your principal will becomes 9 times of itself in only 60 years instead of 120. That's the basic difference between SI and CI. Now, this is a conventional method to solve these kind of questions. Is there any shortcut? Let's see. If you deposit 100 rupees in bank under CI, it becomes 300. After how many years? 30 years. So I know that my bank can triple my money in every 30 years. What will happen here? Exactly after 30 years, I'll withdraw these 300 rupees, and after a few more minutes, I'll deposit this 300 in a bank for 30 more years. What will happen? We know that bank can triple my money. Now the principal will become 300. 300, triple of 300 will be equal to how much? 900. So effectively, it took how many years? 30 plus 30, 60 years. Now, this is the shortcut of computing. This shortcut to be used for these kind of questions. Fine.